Hey all, I'm going to show you how to do some data analysis in a program called Jamovi. I like Jamovi a lot because it uses the R programming language, but puts like a really user-friendly drop-down interface over it. Now it only does a couple things, fairly basic statistics, but for a lot of the purposes you need in organizational settings, if you're doing just straightforward kind of like engagement surveys, it probably will serve your purposes just fine. So if you Google Jamovi, you can see it Jamovi, right up there. You should be able to download this and just run on your computer. So once you do that, you can go into it and you can do import. And the file that we have given you for this assignment is a excuse me, CSV file. You can import a couple different types of files. I'm not going to show you this example with our data. I'm going to use some different data that's similar. So I'm going to open up the data set. Okay. Now you can see I've got all the different variables listed here. It looks very similar to how the Excel file would look, except for it has these official little headings here. For any given variable, I could go in and I could tweak it. So here's the scales that were already created for each of the variables. But you can see like I could go in and tell it, let's see. Like this is an item about developmental opportunities. What thinks it's nominal? It actually is a continuous variable, so technically that should be continuous. That's not that big of a deal if they're not being entered correctly. The only thing is for certain analyses, you can only do it on a nominal or continuous variable, so it wouldn't let you actually do it on that variable if it had the wrong labeling. The data type, right? Then if you wanted to like create a new variable, you could do add variable. You can just insert one. You can actually copy paste a variable. You just do copy, and then over here you would do paste. You could create a variable if you do data compute. So like if I want, full scale for engagement, I can just give it the command mean of engagement 1. Typing this very well, but whatever your variables are labeled. We've already done this scale creation for this, but then you would just press enter and it would do it. And it tells you the various functions to use. All right. So pretty cool. You can do a lot in here. Anyway, I messed up the way I was typing it, so it's not working, but I'm just going to delete that variable. Anyway, point being, there's a lot of different stuff you can do to play with the data once it's in here and get the variables or the actual data itself in whatever kind of form you want. But let's go to analyses. So the most basic thing you would do here, and let me tell you before you start, you want to go over here and you want to make sure syntax mode is clicked, because that's going to paste in the syntax of what you would use. I don't need those references to be there. In R. So you could literally paste this. You could. Oof, it's not letting me easily copy that. I could copy that and then paste it into R or export it into R. And so I could rerun this anywhere, which is really nice. And now you might have learned, you'll notice some of the syntax with stuff we do, you learned it in R in your other class, your statistics class, but it might be slightly different. There's a lot of different ways to do stuff in R. This is one way. And this is nice too. If you're going to do something more sophisticated, you can kind of use this as a base and then build off of it, because you'll have the syntax done for you. All right. So if you go to exploration, that's going to give you your basic descriptive statistics. So this is a data set that has just like ours, a lot of predictors and a lot of outcomes. So we're going to focus on, let's say we're looking at engagement. Let's just look at, we want to see the mean level on our outcomes. We have job performance, engagement, org commitment, and counterproductive work behaviors. So I just arrow them over, click over here, and voila. You can see I have output. There's the R code. There's what it gives you. Very nice, right? You can click down here and you can change some of these. This will look like this. You click that, you could change, like if you want to also get the standard deviation, you add that. And notice it just automatically shows up, and it changed that to add an SD there. I could get a histogram. Takes a minute, but yeah, see. So it's showing me the distribution of all the variables. I can see these are obviously quite skewed. And anytime you want to go back to an analysis, like I could scroll up, click this, and it'll bring up this left frame that shows all the stuff I put in to produce that analysis. I'll show you what I mean in a second. When we do more, we can come back to this one easily. You could also split the data. So let's say I wanted to see the means by gender or something. Then I could put gender in there. Just give it a second. It's sort of weird because you never like actually press like go or run. It just sort of does it. Now it's telling me my gender 1, 2, 3. So this data set has 1 is male, 2 is female, 3 was an other choice. So you can see up here the sample sizes are just 1 in that other category, but it's break. So you don't really want to interpret this because it's just one person. But for the 1 and the 2 category, the male and the female, it's showing you the means for each of those and then histograms separately. So that's pretty cool. So real easy, just kind of getting a sense of the data with this descriptive type stuff. All right, now let's say we want to let's say we wanted to do a test where we wanted to see if there were actual differences in a mean based on a grouping variable. So instead of just eyeballing like the males and females in the analysis we ran before, I want to know, are they statistically significant differences? So anytime you're comparing 2 groups, remember that's an independent sample t-test. So I'm not going to use gender because we actually have 3 categories of that. I'm going to use manager because it says 0 for not manager, 1 for somebody who is a manager. And I'm going to say, is there a significant difference on engagement? So the outcome, the variable goes in the dependent, whatever the groups are defined by is the grouping variable. Now you can see it's giving me a t-statistic of -1.26 and the corresponding p-value is 0.212. Now remember, we want the p-value to be less than 0.05 to say something statistically significant. We're doing a two-tailed test at the standard alpha level. So this would tell us there are no differences based on managerial status and engagement. And you probably want to check descriptives here because I'll also output the means for both groups so you can interpret them. That negative is not really meaningful. It's just based on the way it's subtracted it, based on how it's coded. But you look at the means, you can see the trend is such that managers have higher engagement, but it's not significantly significant. So we would not interpret that as different. Now let's look at something that is significant. So let's say I do want to look at gender, but we only have 1 person in that other category, so it's not going to be meaningful. So let's go back to the data. Let's find the gender variable. Where are you, gender? There it is. So there's that person that's a 3. There are ways to do this with syntax. I'm just doing the real quick and dirty way. I'm going to insert a variable. I'm going to call it gender new. And then I'm going to copy this one. And I'm just going to manually delete that person that's a 3. So now I have a variable with just 2 levels. I didn't mean to click that. Now I'm going to go back to t-test, independent samples. And now this is what I was saying before. If I click this, it shows me exactly what I had in those boxes before. Gender new is my grouping variable. Let's say I want to look if there's differences. Does pay variables, fairness and pay? We know there's tends to be a gender pay gap. So let's see if it comes out here. And indeed it does. So this is 3.7 is the t-value, and that's significant. P is less than 0.001. Click that descriptives box again. And it shows us the mean differences. Indeed, male is coded 1. Men are believe their pay is significantly more fair than women do. Perhaps not a surprising finding. Now notice this subscript A, it says Levine's test is significant, suggesting a violation of the assumption of equal variances. So if you remember when you talked about t-tests in your methods class, the assumption is that the 2 groups have equal variances. The Levine's test tests that assumption. Here it's telling us the assumption is not met. So if that's the case, that's when you want to use this Welch's T, which adjusts for that. Often it's going to give you the same info. Notice it's this T statistic's a little bit bigger, still significant. It adjusts the degrees of freedom. That's how it handles it. But we would interpret the means the same. So if that Levine's test, if it tells you you have a violation of that assumption, that's when you want to use the Welch's. And you could do more assumption checks here. This is telling us it's also violating the assumption of normality. This would just be another way of looking at normality. You know, in practice, you're not really supposed to run these tests if they violate the assumptions, or in theory. In practice, people really do. There's an easy adjustment for that equality variance one. Normality, I'm not sure to what extent you talked about in your classes, but there are some things you can do with transforming the data. I'll be honest, most of the time people don't do that. So I would just for our exercise move forward even if it violates those assumptions. Although that is not technically what you should do. Okay, so that's a t-test comparing two groups. Let's say I wanted to independent sample t-test, that's what that was. Let's say I wanted to compare like our engagement scores to some other organizations, like as a benchmarking thing, and I wanted to know, are they significantly different? I could put in this box test value. So let's say the other organization had an engagement score of 3.75. I want to know if ours is significantly better than that. Notice it's telling me it's comparing our average, which is a 4.05 to that 3.75 and saying, yes, indeed, ours is significantly higher. So I don't think you'd be doing anything like that for the assignment. Or probably not necessarily any type of t-test, but just kind of trying to refresh you if you did want to look at some group differences. And ANOVA would be, recall, we're talking about a one-way ANOVA. There's a lot of different types of ANOVA, but if you have three groups, so your grouping variable has three levels. In this data set, tenure is trichotomized, so how long you've been with your organization. So 1 is less than 5 years, 2 is 6 to 10, and then 3 is greater than 10. So let's say if we want to see if there's like a difference in what would be a good outcome? Commitment, maybe, based on your tenure. Now, that's telling us the overall F is not significant. So there are no significant differences across in organizational commitment across the 3 tenure categories. If that had been significant, then what you'd want to do is click this post hoc test. Typically, you want to run a 2 key. And that will show you if the overall F is significant. That'll explain to you where the nature of the significant differences lie. So this is comparing group 1 to group 2. That's the t-value, not significant. 3 to 1, that's the t-value, not significant. And then comparing 3 to 2, again, not significant, because our overall F is not. None of these are going to be. But if that was significant, at least one of them would be, usually. Okay. So now let's get on more to regression, which is more of what you're going to be using for this class assignment, I think. So before you do a regression, you should really start with a correlation. And there's a couple reasons for this. First, it just gives you a sense of the general pattern of the data. I like to use this before regression to avoid what's called suppressor effects and to preserve power. So if you put everything into a regression equation, you're going to reduce your degrees of freedom, thereby reducing your power. You also could, if there's a lot of multicollinearity, meaning variables are super highly correlated, you can create some weird things with the data. You can have what's called a suppressor effect, where something that's not significant becomes significant and the sign changes greatly. It's just kind of a statistical artifact. So I think looking at the correlation matrix is just a cleaner way to take a first stab. So what I put in, let's put the dependent variables first. Let's just focus on engagement and commitment for this example. And then our predictors of that were purpose, autonomy, pay fairness, person job fit, and self-efficacy, and clearly communicated expectations. All right. And I've told it to give me a little, I'm going to do flag significant correlations just because it's easier to interpret that way. But remember, we're looking this is, for example, telling us the correlation between commitment and engagement. Those are our two DVs. Let's look at purpose and engagement. Let's say the correlation is 0.4 and the p-value is very small, less than 0.01, so that is significant. Told it to flag significant ones, but I don't. Let's see where it's actually flagging anything, which is weird. Anyway, we can just look at it ourselves and tell which one's significant. So let's start with engagement. So engagement is significantly correlated with purpose, autonomy, because less than 0.05, not with pay, PJ fit's significant, self-efficacy significant, and clear expectations. So a lot of stuff significant there. And then let's go and look at commitment. And I wrote this down with engagement. For commitment, it's purpose, nothing with autonomy, not significant with pay, fairness, significant with PJ fit, not significant with self-efficacy, but significant with expectations. So I would then build my regression equation just based on those that were significant in the overall correlation. Like I said, you're not going to see something go from being significant in a correlation to, or not significant in a correlation to significant in a regression unless some weird kind of stuff's going on, because really you're taking away variance in a regression when you include other variables in it. So it should really only get smaller or less significant, less likely to be significant. Okay, so now I'm going to linear regression. My dependent variable, let's start with engagement. And we said engagement is significantly correlated with purpose. And you're going to put these in the covariates box. If you have a dichotomous variable, a nominal variable, you'd put it in the factors. We don't have any of those. We could like put gender in if we wanted to see if that was a predictor. Purpose, autonomy, PJ fit, self-efficacy, and clear expectations. All right. Now, those are all going in on the first block. You would use multiple blocks if, let's say, you wanted to put everything in one block and then you wanted to see, like, is there a significant change if I add in another variable? Like, does it account for incremental variance above and beyond the others that are already in there? For our purposes, probably not necessary. You could do some assumption checks. I'm just going to skip over that to keep things simpler for this. I like to have the overall model test, and we want standardized estimates. That's just if our variables are measured on different scales, it puts them all on the same scale. Well, it's for ease of interpretation. And then I'm not going to go into marginal means. Okay. So regression is run. This tells us our overall R squared is 0.224. That means that 22.4% of the variance in engagement is accounted for by our set of variables here. That's pretty good. Our F value is, here's the degrees of freedom for the regression, is significant. So now we look here. Which ones remain significant in this? Purpose does. That p-value is less than 0.05. But interestingly, none of the others are now significant. So purpose is a strong predictor here, and that shared variance with purpose is making it so, or with some of the other variables, none of the others are unique predictors. So purpose seems to be what really matters for engagement. So that would be like the conclusion I could draw from this analysis, right? It's the only one that remains significant. Now I'm going to put commitment as my DV, and we said commitment was significantly correlated with purpose, PJ fit, and expectations. So I'm going to take everything else out. I'm accounting for 17% of the variance in commitment, significant overall equation. Now purpose and expectations are the only ones significant. PJ fit is now no longer significant. So I could conclude that purpose and having clear expectations seem to positively impact people's commitment because those are positive beta weights, right? So story seems to be in this, with this organizational sample, purpose matters a lot. So that's the basic gist, I think, of kind of the stuff you would need to know. A refresher. Again, I know you talked about this in your previous classes. You can do a lot more in here that I'm not getting into, like you can do chi-square type stuff. I just don't think you necessarily need it for our purposes for our class. What's really cool about Jamovi is you can do a confirmatory factor analysis, which you cannot do that easily or maybe at all in SPSS or most other programs. You have to use something like M+. You could do it in R, but it's a nice, easy way to do it here. So for your assignment, just think about kind of what do you think what would someone want to know if they were in Barbara Norris's situation, and what's the interesting stuff to report, and what make sure you interpret things aligned with the statistical significance, and that you paste in this output to show how you drew those conclusions. Okay, so I think that's it. George and I will hold some virtual office hours for anybody who's working on this and has issues. We're happy to help you and kind of walk you through it, because I know statistics can be very frustrating if you just kind of get stuck and it won't do what you want it to do. All right. Hope this was helpful.